Hey guys, welcome back. Today we're going to talk about one more Riemann sum, although since it's not a left or a right, we don't call it a Riemann sum, but it's the same idea. And based on the title of this lesson, I bet you can guess we're going to use trapezoids. So, quick review of what we did yesterday. So, if we use a left Riemann sum, we start on the left, and the height of all of our rectangles is starting from the left end point, and it's the height at 1, and you work over. And then you go over again and blah, blah, blah. So a left Riemann sum starts with the left end point and ends up not using the right end point. And here's all the work we already did. We're not going to do, that's the actual area under the curve. We're not going to do that again. Here's the left Riemann sum. Okay. And then a right Riemann sum would start on the right end point. So you start here, go up to the curve, and go over from there. That would be a right Riemann sum, and that ends up being an overestimate, okay? And you don't end up using the height on the left. So those are the ones we did yesterday, and we also did a midpoint rule yesterday. So now, let's see if we used a trapezoid to fill in the area, that might be a little closer. So let's first just show it. That's the right again. Okay, here's your trapezoid. And notice how much better that estimate is. The area of the trapezoids is way closer to the actual area of the curve, under the curve. So now we gotta remember how to find the area of each of these trapezoids. Okay, the formula for the area of a trapezoid is 1/2 the height times the sum of the bases. But these trapezoids are sitting sideways, so let me draw you another one. That's kind of messy, but you get the idea. If this was a trapezoid, the height is the perpendicular distance that connects the two parallel bases. Okay, so in our graph, the bases are going to be these heights. And then the height is sitting this way, sideways, because these are sideways trapezoids. Hopefully you can see that, okay? So in order to find the area of each of these trapezoids, I'm going to end up using all of these heights, all of these numbers, and I have to find the height at all of those. So I'm going to plug all of these numbers into the equation to find the designated heights. So those are all of the heights. Now let's do the trapezoid rule. The integral from 0 to 4 of x squared plus 1 is approximately, okay? Bunch of trapezoids. 1/2, we're going to look at this first one. The height is this guy times the sum of the two bases, 1 and 2. Okay, basically you end up using all the numbers for a trapezoid rule. Okay, then the next trapezoid would be this one. Okay, so it's 1/2. The height is 1 times the sum of the two bases, 2 and 5. Next one, this guy. The height is 1, so it's 1/2. The height times the sum of the bases, 5 and 10. And last, this guy, 1/2 of 1 times the two bases, 10 and 17. Ran out of room. 10 plus 17. Okay? Now, obviously, since you did 1/2 and 1 for all of these, you could have wrote it out in front of parentheses like you're distributing, factor it out. So you could write the 1/2 one time, but I find if you write it every time, it kind of helps you remember it. So anyway, then you do the math, add this up, and that's your trapezoid rule, okay? So adding that up, taking half of each piece, okay, and when I add all of that up, 27 plus 15, that'd be 42, 52 over 2, which is 26, okay? So there's your trapezoid rule. Now let's do it with one that's not graphed for you. Remember, for the trapezoid, you basically have to use all of these numbers. Okay, take a moment to read this one. I want you to think about why we're even using a trapezoid rule. Why are we doing an integral, in other words? This is just an estimated integral. Okay, if this is velocity, feet per second, then when you integrate if you integrate feet per second, when you integrate that, you just get total feet, which is distance, okay? Okay, so this one wants only 2 subdivisions, so if you can't visualize how to set that up, I'm going from 1, 2, 4, 7, and 8, using only 2 subdivisions. Yeah, I wouldn't do that. I got to change that. This would not be 2 subdivisions. This would be divided as the data is shown. So I'm going to change that. Let's make it 5 subdivisions. Okay, so if I were to graph it, my trapezoid, this would be up 14. This would be up 20. This would be up 10. This would be up 15. And at 8, we'd go up 2. Those are my trapezoids that I'm finding the area of, okay? If I wanted to graph it, which you don't have to. So, the integral from 1 to 8 is approximately, bunch of trapezoids, ready? 1/2 of, this is 1 times the 2 heights, here and here, which are 14 and 20. Now try to look at the table and not use the graph. It was 1/2 of 1, which is what you get when you subtract these, times the 14 and the 20. You end up using both endpoints. If it were a left Riemann sum, you would have used just the 14. A right Riemann sum, you would use just the 20. Trapezoid rule, use both of them. That's it. Okay, the next trapezoid would be 1/2 the height, which would be, subtract that and you get 2, times, use both endpoints, 20 and 10. Okay, the next one, 1/2, the height is 3, and we use the 10 and the 15. And the last one, why do I keep running out of room? I haven't learned my lesson yet. The last one is going to be 1/2 of the height, which is 1, and use both numbers, 15 and 2. Okay, do that math, and that is your estimated integral, or distance traveled in this one. Okay, I assume you can do that math. I'm going to leave that one for you. Now, hit pause and read this problem. Please actually read it. Read the whole thing. This is actually an AP free response question. You always get a free response question with the table, okay? And I want you to think about why you're even using an integral or an estimated integral for this problem. So read it very carefully. Hit pause. Okay, so first, hopefully you read carefully and you saw that they only want us to deal with the first 4 hours. That means this is the only relevant part of our table. Okay, so we're going to ignore this. And this, by the way, is the first problem on your worksheet today. Your worksheet today is all former AP questions, and I want you to read carefully and make sure you understand why you are doing an integral. Yes, it's an estimated integral, but it's still an integral, and you want to try to read those words because sometimes they don't tell you that, okay? This one, it was pretty clear. They said use a trapezoid rule. So try to learn while you're doing your worksheet today, because it's only 6 problems. Try to really read the questions and understand why it's an integral to begin with. So this one, we're actually going to be integrating just from 0 to 4 using our trapezoid rule. Sorry about that. Okay, so we're only using this part, using a trapezoid rule. But why is this a trapezoid rule anyway? Why can't I just add these numbers up? Why is that? Why do we need an integral? Well, if you think about it, this is just a snapshot at time 0, at time 1, at time 3. But what about at time 2? What about at time 2.1? What about time 2.5? There are lots of numbers in between. And that's what that integral is doing, taking all the other times into account. Okay? So I'm not going to do this problem for you because now that I've pointed out that it's only the first 4 hours, now it's on you, and this is on your worksheet, the first problem. Okay? Good luck, guys. Hope you're doing okay, and let me know if you need anything. Bye.